Hello, my darlings. So far, our tools for integration. We've looked at the graphs. Can we find the area that's under the curve? We've looked at finding the antiderivative. We have algebraically simplified a function and then found the antiderivative. We have done trig substitutions and then found the antiderivatives. We have done U substitutions, which remember reverse the chain rule. So the U substitutions were to reverse the chain rule. Well, today we're going to learn how to reverse the product rule. Yay! Let's start by looking at the derivative of a product. So the derivative of a product would be, we keep the second part, take the derivative of the first, plus keep the first and the derivative of the second part. So I'm just writing du to mean the derivative of the u. Okay, now if I was to integrate both sides of that equal sign, we know that the integral and derivative are inverse operations, so on the left-hand side, we're just going to get uv. On the right-hand side, we're going to have the integral of v du plus the integral of u dv. So far, so good. Now, I can do anything I want to one side of the equation as long as I do it to the other. So what I want to do is I want to take this integral and I want to move it to the other side. So I'm going to have uv and I'm going to subtract the integral of v du, and that leaves me with the integral of u dv. And this is actually what we call integration by parts. And this is how we undo the product rule. So when we have an integral, we try to determine a u, which is a function, and a dv, which is the derivative already that we'll be able to undo. And when we integrate those, it's going to be u times v minus the integral of v times the derivative of u. And of course, you are going to have to do the integral again. Now, the hard part of this sometimes is picking your u and your dv, all right? In general, it's helpful sometimes to let dv be the more complicated part, okay? That you can easily take the antiderivative of, that you can find the antiderivative of. And u is the part of the integrand whose du is a simpler function than u. Sometimes you'll see it sitting right there. Another method that I learned recently is liate. You're going to choose u, so this helps you figure out u, in the order of this list. If you have a logarithmic function, that's your u. No log, you look for an inverse trig function. That's your u. No inverse trig, you look for an algebraic function or a polynomial. That's your u. If you don't have that, then you look for a trig function. That's your u. If you don't have any of that, then you let the exponential function be your u. Okay? So we'll use that to help us out. And the last but not least, guys, you only have two choices. If one choice doesn't work, switch it around and try the other. So if you picked something for u and something for dv and it doesn't work, reverse them, okay? Now, when we do this, we're going to choose our u, but that means we're going to have to also figure out what du is, and that's just going to be the derivative of whatever we chose u to be. Not only that, when we choose dv, we have to figure out v, which is the antiderivative of whatever we set dv to be. Okay, it sounds like a lot, and it sounds very obtuse, but it's not too bad once we start getting going. Let's try a problem and see if it makes sense. So the first thing I'm going to do is I'm going to put our rule for integration of parts here. The integral of u dv equals u times v minus the integral of v du. And remember our little acronym, liate. Okay, so when we look at the integral of x cosine x dx, do we have a log? Nope, no logs. Do we have an inverse trig? Nope, no inverse trig. Algebraic? Yes. We have x. So x is going to be our u, which means du dx, the derivative of both sides with respect to x is 1. So my du is just going to be 1 dx or dx. Now, that means that the other piece, the cosine x dx, notice the dx has to come with it, that's all our dv. And in order to find v, we have to find the antiderivative. The antiderivative of cosine x dx is sine x, okay? Now, it is true, you do not have to write that step. You can just look and say, oh, the antiderivative of cosine x is sine x. I'm absolutely okay with that. All right, so now we use our rule. We say u, which is x, times v, which is sine x, minus the integral of our v is sine x times du is just dx. So we need to bring along our x times sine x minus, now what's the antiderivative of sine x? That's a negative cosine x, so this becomes plus cosine x. And don't forget your plus c. There you go, you did it. That's what it is, okay? Let's try another. Okay, so now we have the integral of x times e to the negative x. So the first thing we want to figure out is what is our u. Do we have a log? No. Do we have inverse trig? No. Do we have an algebraic function? Yes. We have x. So that's our u, which means du dx, the derivative of x is 1, so du is just dx. That means that everything else that's left is our dv, e to the negative x times dx. Now if we take the antiderivative of e to the negative x, that's an e to the negative x divided by negative 1, or just negative e to the negative x. Everybody okay so far? All right, now let's use our rule. We need u, which is x, times v, which is negative e to the negative x, minus the integral of v, which is negative e to the negative x, times du, which is just dx. Now we can take this double negative and make that positive. Okay, so what we're looking at here, we've got negative x e to the negative x plus the integral of e to the negative x dx. So we're going to keep the first part plus the antiderivative of e to the negative x. Didn't we just do that over here? It's negative e to the negative x, and don't forget your plus your constant. There we go. We've done two. Let's try one more. Okay, so we're looking at our function. Do we have a log function? Ooh, yes, we do. Okay, so our u this time is the natural log of x, and du dx, the derivative natural log of x, is 1 over x, which means that du is 1 over x dx. Okay, this time we're solving for du, not dx, like in our normal u substitutions. This also means that dv is everything else that's left over. That's x cubed dx. So when we take the antiderivative, we add 1 to the exponent, and we divide by that new exponent. So our v is x to the 4th all over 4, or 1/4 x to the 4th is fine too. All right, so now here we go. We follow our rule. Our rule is the natural log of x times v, which is x to the 4th. I'm going to put that in front of the natural log so it doesn't look like it's inside and that we're taking the log of that. And I'm going to put a 1/4 in front minus the integral of our v is x to the 4th over 4 times the du is 1 over x times dx. So far we've got that 1/4 x to the 4th times the natural log of x minus the integral. I'm going to pull that 1/4 out of here, but also, see this x to the 4th and this x? They're going to simplify to x to the 3rd, aren't they? And then we still have dx. So again, we're looking at 1/4 x to the 4th, and we still have times our natural log of x, minus, bring down my 1/4. Now when I take the antiderivative of x to the 3rd, I add 1 to the exponent, divide by the new exponent. Let's not forget our plus c at the end. And let's see if we can simplify that a little bit. We still have 1/4 x to the 4th times the natural log of x minus, now we've got 1/16 times x to the 4th, and of course our plus c. There we go, guys. So you have learned how to reverse the product rule by using integration by parts. Have a great day. See you soon.